So today we will discuss about the common ion effect. Basically, it states that it is like in the common ion effect it is the suppression of it is a suppression in the dissociation. It is a suppression in the dissociation of the weak electrolyte in the presence of a strong electrolyte. Right. So basically, let's look into the example. Like there will be suppression in the dissociation of a weak electrolyte in the presence of a strong electrolyte. Consider that we have a weak electrolyte which is hydrogen cyanide. It is a weak electrolyte, and consider that we have a strong electrolyte which is potassium cyanide, right? So as hydrogen cyanide is a weak, so there will be equilibrium H positive plus Cn negative, and there will be here it will be the 100% dissociation. Here it will be 100% dissociation, right? And here K positive plus Cn negative will be formed over here, right? So as you can see over here we have two common, like here I forgot to add having two, like they should have two common ions having common ions, right? As you can see over, this is a common ion, this is a common ion of same. So what is the state? Now as you can see over here the concentration of cyanide ions is very high. So the equilibrium thing that according to the Le-Chatelier's principle, when the reactant or for example product concentration increases, or you can say there is a certain stress, or you can say when the equilibrium get disturbed, it tries to get the same equilibrium position by changing the direction of the reaction, right? So obviously what will happen in order to balance this concentration of Cn, consider Cn, it will do a backward reaction. It will do a backward reaction, right? And as you can see that before the reaction already HCN is a weak electrolyte, there was a problem in the dissociation. Now there is more problem, like now they are forming, like HCN is being formed in order to maintain the stable equilibrium, right? So this is basically what the common ion effect is. Okay, let's take another example. Okay, for example we have a weak acid which is CH3COOH, right? And we have a strong acid which is HCl, right? This will dissociate. CH3COOH will basically dissociate into CH3COO minus plus H ions, right? And this will obviously here will be 100% dissociation, right? And here it will be H plus Cl negative. As you can see over here, now this H plus and this H plus both are common ions, so again the reaction will be shifted to the backward reaction will proceed. Why? Like, who, if someone asks you what's the principle behind this mechanism, so the principle which is included behind this mechanism is the Le Chatelier's principle. Le Chatelier's principle. So now let's look into the applications of this common ion effects. The application of common ion effect. Okay, basically it is used in order to purify the sodium chloride, to purify NaCl. Basically this NaCl is being extracted by the process of mining. It is extracted by mining. So basically in this NaCl there are certain soluble salts and certain insoluble salts. Soluble salts and insoluble salts. If we talk about the soluble soluble salts, we will talk about this later. We consider that we will make the brine solution. What will happen? Basically, we will take a container and mix NaCl into this and water as well, and we will basically make a saturated solution of NaCl, right, and which is known as brine, and this is water. And here we have add NaCl and H2O. Right, so this solution is basically saturated and it's also known as concentrated. There is an MCQ in the Federal book as well, which says that this solution is concentrated. Now, after making the brine, we will use filter paper and we will filter this. So by filtration, we will basically we will extract out the soluble salts. Sorry, insoluble salt. Insoluble salt can be easily extracted by this process. But for the insoluble salts, what will happen? For insoluble salt, we will put, like this is NaCl, there will be NaCl, and we will put HCl into this. When we compare NaCl HCl is more stronger than NaCl, so there will be complete dissociation of HCl and there will be the partial dissociation of NaCl. Right, as you can see over here, basically we will add HCl in this in order to get the insoluble salt, right? You can see over here the Cl is a common ion, right? So the reaction will basically move backward and it will basically form the crystals will form, or you can say the process of crystallization will take place. Crystallization takes place. So after the crystallization, as we will get the soluble salts as well, so this is how the NaCl is basically purified through the process of common ion effect. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you guys.